Hello and welcome to Maths with Jacob. This lesson will focus on start with a simpler version. That's with respect to problem solving. Sometimes it is easier to solve a problem by starting with a simpler version of the original problem. Gradually increase the difficulty of the simpler problem until you see a pattern emerging. This will enable you to solve the original problem. Example 1. 6 men compete in a sprint race. At the end of the race, each athlete shakes hands with every other person. What is the total number of handshakes? So let's start with the simplest possible version. If there are 2 people only competing against one another, there's only one handshake. So that's the simplest version. Now we have 3 people competing. Now the best way to do this is in the form of a table, where you have A, B, C here, and A, B, C there. And A, B, and C represent the 3 people. Now, don't worry about the meaning of these just for now. All we're going to do is fill in each cell, and then I'll explain what the meaning is. AA is there. AB is there. AC is there. BA is here. BB is there. BC is there. CA is there. CB is there. And CC is there. Now, let's have a look at what each of these means. Firstly, let's focus on these 3 red cells here, AA, BB and CC. Exclude the red shading because each man does not shake hands with himself. In other words, this means that A shakes hands with A, but that doesn't happen. B shakes hands with B, and C shakes hands with C. That does not happen. So they're excluded. Next, exclude the blue shading because each of these is a repetition of the ones which are shaded green. This means that B shakes hands with A. That's exactly the same as A shaking hands with B. That's why we exclude this cell. And that's why we exclude this cell, because it's the same as AC. And that's why we exclude this cell, because it's the same as BC. Hence we have 3 handshakes. And the 3 handshakes are in green. So the greens are the ones that are left, because we've excluded the red, and we've excluded the blue because of repetition. So, for 3 people, there are 3 handshakes. Let's see what happens with 4 people. So here's the table, similar to the one we've seen on the previous slide. These are the shadings. Exclude the red shading because each man does not shake hands with himself. We've explained what that means on the previous slide. And exclude the blue shading because each of these is a repetition of the ones which are shaded green. Hence we have 6 handshakes. So for 4 people we have 1, 2, 3, 4, 5, 6. 4 people we have 6 handshakes. Now in the same manner, when you have 5 people, here's the table here, and the 5 people are A, B, C, D, E. We fill in the cells appropriately. We exclude the red because each person does not shake hands with himself. We exclude the blue because they are repetitions of the green cells. Hence, we have 10 handshakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In other words, when you have 5 people, you have 10 handshakes. Now let's have a look at the summary on the next slide and see if we can pick some patterns. Now let us see if we have a pattern. So if we have 2 people, there's 1 handshake. That's easy. If we have 3 people, we've seen that we have 3 handshakes. To go from 1 to 3, you just add 2. If we have 4 people, we have seen that there are 6 handshakes. From 3 to 6, we just add 3. When there are 5 people, we saw how we have 10 handshakes. To go from 6 to 10, you add 4. So each time you increase the number of people by 1, this is what happens. You have plus 2 from 1 to 3. You have plus 3 from 3 to 6. You have plus 4 from 6 to 10. Therefore, you have plus 5 from 10 to 15. So in other words, when you go from 5 people to 6 people, the handshakes increase from 10 up to 15 if we follow the pattern. Hence, with 6 people, we have 15 handshakes. So we've seen how to solve particular problems by looking at a simpler version, starting with a simpler version, and working our way through gradually until we see a pattern emerging, and that helps us to solve the problem that we are given.